Yeah. Hi, students. Uh, Greetings from my side. So, thank you for being here. So, I'm about to teach you one of the courses which is running in our university, which is known as Measurement and Metrology. So, let me share first my presentation, and then I'll be briefing you about how this course is, what are the challenges, and what are we actually going to learn in this particular course. So let me share my presentation with you. So yes, so I hope my screen is visible to you. So here is my presentation. So let me talk about that. So here I'll be talking you about the measurement and metrology. So what do you mean by measurement and metrology? So suppose here I wanted to measure something. So suppose your life, if things are not measurable. So say you can see over here, I'm showing you how many fingers. So in my hand, I'm having 5 fingers. So suppose if I'm not able to calculate, if there is no maths, so how my life will be? So it would be very difficult for us to continue our life. Day-to-day activity will be very difficult. So measuring is very important, or I would say the phenomena by which, or the science by which we actually measure things. So that science is actually known as metrology. So let me talk about few of the terminology associated with that. So in this presentation, I'll be covering the linear instruments, then surface plate and slip gauges. So these are few topics I'll be covering in this particular lecture. So firstly, linear instruments. So what do you mean by linear instrument? So herein you can see that I have shown one of the examples. So let me elaborate one of the example. So suppose this is the cover, or I would say mouse cover I'm having. So I wanted to measure the dimension of this particular cover. Say I wanted to measure this particular dimension and this particular dimension. So this is a square or rectangle kind of cover, and I wanted to measure its both the length and width. So how can I actually do that? So I believe for you, the only answer is, because I believe all of you are having ITI or 10 plus 2. So you must have seen one instrument which is known as scale. So scale, I actually, if I wanted to measure this particular specimen dimension, say length and thickness, so I required a scale. So scale is a measuring instrument by which I can measure length, dia, height, thickness of a particular specimen. So either it could be a external measuring, I would say external measuring dimension, or it could be the internal dimension. So if I actually classify these linear instrument, so these linear instrument can be further classified as direct measuring instrument, indirect measuring instrument. So if I pick this particular specimen and I'm going, if say I will start measuring my dimension directly placing a scale just beside to this particular specimen, then this particular measurement is known as direct measuring it, and the instrument required for that is direct measuring instrument. And suppose in case I'm converting my dimension using some instrument, suppose my instrument is able to sense magnetic field, electrical field, or any optical signal, any pneumatic signal. So suppose my instrument is converting these signals and using the secondary transformation, it is converting that into my displacement, length, dia, height and thickness of my specimen. So these kind of instrument, those who are calculating these dimension by using any secondary transformation, so these kind of instrument is known as indirect measuring instrument. So herein you can see that this is not the focus of my presentation, so I'll be mostly dealing with the direct measuring instrument. So direct measuring instrument is further classified as graduated measuring instrument or non-graduated measuring instrument. So you must have seen the scale. So scale is having some division, so that I'll be showing you in the further slides also, but for the sake of the learning over here, so scale is having division. So you must have seen that. So scale is having 0 to 15 centimeter, and within 0 to 1 centimeter, it is having 10 divisions. So one division is equal to 1 mm. So if any instrument is having scale, or I would say division on, if any instrument is having some division, which is actually specifying the dimension, so that instrument is known as graduated measuring instrument, wherein if my instrument is not having these kind of scales, then my specimen or my instrument is known as non-graduated measuring instrument. So further I have written some of the examples related to the graduated measuring instrument. So some of these are scales. Then further I have listed some of vernier caliper and micrometer. There are few more also, so I'll be elaborating that in further slides. Wherein non-graduated measuring instrument, wherein there is no measuring scale on my instrument, so these are known as non-graduated measuring instruments. Some of the example I have listed over here, so that I'll be covering in my further slides. So these linear instrument wholly can also be classified as precise measuring instrument and non-precise measuring instrument. So precise measuring instruments means, suppose I wanted to measure a dimension which is 1.36 mm. So that 1.36 mm is very precise. Say using a scale, I can measure 1 mm, 2 mm, 3 mm, 1 centimeter, 2 centimeter. But if I wanted to measure up to the second decimal place or third decimal place, that means I wanted to measure very finely or precisely. So the instrument which is required to measure very precisely in, or I would say I wanted to measure very precisely, so that instrument is known as precise measuring instrument, and other one is non-precise measuring instrument. So let me move further and I'll try to show you how